Alright, so today we're going to be looking at conditional statements, a quick little review of conditional statements. And then,
Okay, ladies, please go to Slytherin 2 for your
we're
group to
going to
work
start
together.
talking about the difference
Gentlemen,
between
you stay here,
inductive
okay?
reasoning and deductive reasoning.
Thank you.
In addition to looking at deductive reasoning, we're going to look at the law of detachment
Ladies,
as well
please
as the law
go
of
to
syllogism.
Hufflepuff 2.
And I'll tell you
Gentlemen,
right now
you stay here and work.
that the
Okay.
law of syllogism is going to be on the final exam. Yay! Alright, so here we go. True or false? If false, find a counterexample. The measure of an obtuse angle is less than 90 degrees.
Ladies, excuse
True
me,
or
if you would
false?
go to Ravenclaw 2 and work. Gentlemen, you stay here.
I do want you to
Ravenclaw
answer this.
original.
False. Okay. Can you give me a counterexample? An example of an angle that is great? Okay. So false. And you gave me an angle of
There you go.
30 degrees. Excellent. All square numbers are positive. True or false?
Okay, ladies, please
Every
go to
prime number
Gryffindor
is
2 and
positive.
gentlemen, you stay here. Ladies, girls,
Yeah,
go
that
to
one's a little bit
Gryffindor
trickier,
2
isn't it?
and work together, and the boys stay here.
Alright. And then any 3 points
Okay.
are wholly clean.
So you're gonna go to Math
That is
Fun
true.
dash Gryffindor 2,
Okay, we'll double
and
check
girls are
this.
gonna work together there.
Alright, so we'll double check it.
Gotcha, thank you.
Yeah, that'd be great. The answer is no. So that is a false statement. By the usual definition of prime for integers, negative integers cannot be prime. By this definition, primes are integers greater than 1 with no positive divisor besides 1 in itself. Negative numbers are excluded. In fact, they are given no thought. Well, that doesn't sound fair. All right, so we know that this one is false. Then we know that this one is true. Every prime number is positive. All right, so here we go. Inductive and deductive reasoning. Are you ready, miss? Okay, so last week we learned that inductive reasoning is reasoning that is done by examining a pattern, making a hypothesis, and then testing that hypothesis. And that is inductive reasoning. So in other words, we really need to have some form of experiment that's going to show us whether something is true or not. Deductive reasoning, on the other hand, is not done with an experiment. And if you are a fan of Sherlock Holmes, he is the literary master of deductive reasoning. Or, if you want a little more contemporary example, Jake Peralta in Brooklyn Nine-Nine is a master, although childish, master of deductive reasoning. Deductive reasoning is the process of using logic to draw conclusions from given facts, definitions, and properties. I'll say that again. Deductive reasoning is the process of using logic to draw conclusions from given facts, definitions, and properties. Thought you doing okay? Okay, so here we go. This is kind of fun. Urban legends and modern myths spread quickly through the media. Many websites and television shows are dedicated to confirming or disproving such myths. Have you ever seen Mythbusters? Yeah. You are missing out. That is a great, great show. It's no longer on the air, but it was on Discovery Channel. I think it's because the guy died. Well, that's unfortunate. Other than Shark Week, it's the best thing that Discovery shows ever produced, I swear. So here we go. So we're gonna take a look at some questions, and then we're gonna apply what we've learned from those questions to these examples too. So there is a myth that toilets and sinks drain in opposite directions in the southern and northern hemisphere. hemispheres. However, if you were to observe sinks draining in the 2 hemispheres, you would see that this myth is false. Is that inductive or deductive reasoning? Was there an experiment that was performed? So did we perform an experiment? Did we actually flush some toilets? I know it doesn't seem like much of an experiment. Well, however, if you were to observe sinks draining in the 2 hemispheres, you'd see that the myth is false. So it is inductive because we did perform an experiment and we were able to either prove or disprove it using an experiment. Therefore, it is inductive reasoning. How about this one? There's a myth that you should not touch a baby bird that has fallen from its nest because the mother bird will disown the baby even if she detects human scent. However, biologists have shown that birds cannot detect human scent. Therefore, the myth cannot be true. Is that inductive or deductive reasoning? Right, so they didn't actually touch a bird, hand it to the mother and say, here you go, and see the mother. Right, so yeah, that's an example of deductive reasoning. So let's take a look at these two, see if we can figure out if they're inductive or deductive. There is a myth that the Great Wall of China is the only man-made object that can be seen from the moon. The Great Wall is barely visible in a picture taken 186 miles from the Earth's surface. The moon is 237,000 miles away. Therefore, the Great Wall is not visible from the moon. Is that deductive or inductive reasoning? That is definitely deductive. We are not going to the moon and looking for the Great Wall of China. Right? There's a myth that you can only balance an egg on its end on the spring equinox. A person balances an egg on its end on July 8th and December 23rd. Therefore, the myth is false. Yeah, that's exactly right. Okay. Questions so far? Yes, I am. I'm just not there yet. Okay, so we talked about deductive reasoning. The law of detachment simply says if a statement is true, then the conclusion is true. So, I mean, that's not too hard to follow. So, one thing is true, then the other statement is true. Now, the law of detachment goes right into the law of syllogism, which is a little more useful. And so, the law of syllogism says if P is true, then Q is true. If Q is true, then R is true. Therefore, if P is true, then R has to be true. So I'll say that again. So if P is true, then Q is also a true statement. If Q is true, then R is also a true statement. Therefore, if P is true, R has to be true because of this connection here. So notice how if I'm looking at a statement, this statement is used twice, therefore if P is true, then R is true. Doing okay so far? Well, they're statements. They're mathematical or logical statements. So let's look at an example. All right. So if a figure is a kite, then it is a quadrilateral. If a figure is a quadrilateral, then it is a polygon. So the conjecture is if it is a kite, then it is a polygon. Does that make sense? So in other words, our P statement is if a figure is a kite, so that would be our P. Then it is a quadrilateral, that would be our Q. If a figure is a quadrilateral, so that's a Q statement again, and it is a polygon, that's our R statement. So then, since P is true, Q is true. Since Q is true, R is true. Therefore, if P is true, then R has to be true. A kite is a polygon. That's not too bad to follow, yes? Okay. So if a number is divisible by 2, and is this a valid statement? Is this a true statement? Yes, this is in fact true. So we're going to see if this is a true statement as well. If a number is divisible by 2, then it is even. If a number is even, it is an integer. So those are both true statements. So the question is, if a number is an integer, it is divisible by 2. Is that true or false? That is false. So what is our P value, what is our Q value, what is our R value in this statement here? Okay. All right. Feeling good about law of syllogism? Okay, let's see if you get this one now. If 2y is equal to 4, then z is equal to -1. If x plus 3 is equal to 12, then 2y is equal to 4. So we know that x plus 3 is equal to 12. What's our conclusion? But before I ask you to give me the conclusion, what is my P, what is my Q, what is my R? Sure. Okay, but then I have R here again. Okay, so we're a little that doesn't work so well with what we got, right? So let's try this again. And this one is a little bit confusing because it switched the order of P, Q, and R to be a little extra confusing. So notice how I have 2y minus 4 twice. Well, which value gets stated twice? Okay, you know what? I am not asking the question that I want to ask. I'm sorry, it's my fault. So, if you look at the given, we have P, Q, Q, R. If I look at the given here, P, Q, Q, R. If I look at the given, I need P, 2 Qs, and 1 R. So which value is given twice? The Q. Okay, so that means 2y minus 4 has to be the Q because it's given twice. Does that make sense? Okay, so then that leaves these two things as the P and the R. Now, we're given this value in our conclusion, and the given value in our conclusion has always been called P, right? Or Q, or whatever. That has always been called P, right? So then this has to be our P. So this has to be our value. So what's the conclusion if x plus 3 is equal to 12? Yeah, so z is equal to -1 is our conclusion. Yep, that's it. Or you could say, if x plus 3 is equal to 12, then z is equal to -1. That'd be fine. Are you good? So does that make sense? Okay, so that's what we're doing. So here are the problems that I assigned. I assigned 9 through 13 on page 91, as well as 23 through 27 odd, and then 29 through 34 all. Can you maybe repeat that? Yep. All right. Page 91. Yep.